Hi. That was out of a sudden. So 5 minutes before the time, and we should just start so we have more time to have a look to the ecosystem that not only we, but also other people or contributors build around Neo4j and can be used by you, the Java developers who are interested in getting in touch with Neo4j or already experienced but want to learn what's new in the space. So I'm Gerrit. I work as a software engineer at Neo4j, mainly focused on Spring Data Neo4j currently. And I want to give you some insights how you can approach Neo4j with Java, how you can interact with it, and how to have fun with it. So the first thing I like to take, because I do not know who is in the audience and who has experience with Neo4j or never touched Neo4j before and just came because graph databases are so cool, is how to make the first contact with a Neo4j database. So the first contact would be to get a Neo4j instance running. There are several ways of doing this. For example, you just download the Neo4j desktop. This brings you a full-fledged enterprise version with the latest and greatest version in there. With it, it can handle multiple databases or projects where you can then put in multiple databases. Or it can help you to enable plugins, etc. So you don't have really to care about configurations and similar in text files, but you can just focus on to get a running instance with the behavior you want to see to have it. Enable APOC, for example, if you want to have plugins and similar. And it comes not only with the browser or the console, but it also comes with but it also comes with Bloom. So we get the full pack of Neo4j ecosystem tools already with the instance. And that's not all. You can also get the updates on the fly. So if there's a new Java Neo4j version out there, desktop will notify you and keep the things updated if you want to. You'll get. Sorry, I don't know if it's for me. You don't get urged into updates or similar, but you can also just opt out of them if you want. If you're a more experienced user and know how to set up servers, etc., and you just want to have a more or less clean instance, you can choose you can choose to download the server. So the server is an extractable archive. You can just extract it and run your instance. Also, there's more manual work required to enable plugins, etc. But if you're, like I said, experienced with it, it can be also the choice to go for you. If you do not want to install a server on your machine or to download a desktop application, but you like Docker, for example, you can already get the latest version 4.3 or 4.3 Enterprise via the Docker Hub repository and play with this. So these are the choices when you want to have a local instance running of Neo4j on your machine. And the choice is yours what to take for this. If you don't want to run this Neo4j instance on your machine, you can also go to one of the larger cloud providers and click an instance of Neo4j. But of course, as you have learned today, you can just go to our Aura offering and click the free instance for you if it's enough space that it can take. So you have a free instance running in the cloud. You can connect from everywhere of the world to this and just have fun with this. So doesn't matter how you got the database. One thing is sure, if you get the database in the browser, there will be this movie guide. That's an more or less a standard example we provide in Neo4j to explore subset of a movie database and play with it. Not only the exploring, but also the creating is part of this guide. So the first step in this guide is how to create the data. And if you have created the data, you will get a graph like this. That's the standard output from the query for the data creation. That also does data fetching. So you see an actor, Tom Hanks in this case, acted in several movies or directed one movie also. And then you can also see other directors who directed this movie. For today, just to have something to play with, we keep in focus on Tom Hanks and the movies he acted in. So coming now from the graph world, oops, I hope everything worked. Coming now from the graph world to the data to the Java world, we would somehow with an easy object or class define an actor like this. So an actor has a name, an actor acted in movies, where the movies are not classes or objects right now, just to keep this example simple, but the movie titles. So this is pretty straightforward. We have an actor who has a name and acted in the movies. So starting now, like we did with the installation from inner Neo4j Java to application frameworks, our journey begins right now at the procedures and functions. So how can you utilize Java in the database to provide extended features? One example are procedures. So a procedure looks something like this. We have a name, so when we later will call this procedure via Cipher, we can find it via this name. You can provide parameters, what we want to do here in our case, because we want to find Tom Hanks with his movies he acted in. And it should always return a stream of some data. So for this really simple example and boiled down example, I just said, okay, I will have an actor name that gets provided by the user when she or he calls the procedure. Then I will use the internal Java API to find a node with a person label and a property with the matching actor name. So I get Tom Hanks back at this place, a node that represents Tom Hanks. But from there on, I can manually, in this case, traverse the graph a little bit more. I can query, for example, for the relationships. For the relationships, the actor acted in. So when we recap the image that we had, actor has always an outgoing connection to a movie that says he acted or she acted in. And after this, there comes the stream fun, the Java fun again. We just stream through all the relationships and find the end nodes. And on these end nodes, we pick the title. Collect those titles, collect, of course, also the name of our actor node. And then we will have, with a pure Java API provided within Neo4j, a procedure created that will fetch actors and their relationships. In this case, the movies or the movie titles. We could also do the same by using Cipher. So I now switched from the more discover approach via the Java API to a pure Cipher-based approach. What this does is basically the same. So the key takeaway for this is that you can use either the Java API to traverse the data, or you can just use the API to execute Cipher within the database. So also in this case, Cipher makes it a little bit easier for me in this case here to get the data back, because I now have this record-oriented format. I can just grab the actor's name from the person and the movie titles that I just returned as movies here. Doesn't matter which way you prefer. If you execute the query in the end, you will get the actor and the titles of the movie she or he acted in. That's pretty much all I have to show for the procedures right now. It's cool if you want to have it really in your database and not from a called from an application outside. But given now that we have this functionality, we could also use this procedure from the outside. And I'll show you in a bit how to do this. Because for this communication with the outside, we need some kind of transport. And nothing fits better than our official drivers for this. They use the Bolt protocol, and we provide the Java driver in multiple languages. First of all, of course, Java. That's why you are here today. But we also offer official drivers for Python, .NET, Go, and JavaScript. All drivers have the same subset, or have the same set of functionality. There might be a subset where they behave a little bit different, but all the types, for example, cannot get matched one-to-one as the same in various languages, but on the protocol level, they are all the same. So you can be sure, if you know how to use the Java driver, you're pretty sure how to use the Python driver, .NET Go, or JavaScript driver in the end. Focusing now on the Java driver, this is a common pattern how to use the Java driver in a more explicit way. I create a connection to my instance, in this case, a local instance. To work directly with the Java driver, I need to create a session. And within this session, I call my Cipher. For example, in this case, I just call the method I created in the database. So I want to get all actors, the actors with all titles named Tom Hanks. And this looks pretty much the same as we had before. So I just take the results from my record, parse them, and create a new object out of it. Then I do a clean shutdown, of course, to get everything back. I can now forget about my written procedure. I can just stick with Cipher. So I can exactly do the same now with the Cipher call, the very same Cipher call we have already seen within the procedure, and call this now on the application side to get the very same results back. So both of the calls will provide me the combination of actor name and movie titles again. So this is pretty cool to have. But in modern applications, or at least in modern Java applications, most of the magic happens because you choose to take advantage of you like to take advantage of frameworks, like, for example, Spring. So to cover this, we created more support, or at least helped those teams to have more support for the pure Java driver. So instead of having to go through all the configuration every time you want to create a driver, and then you only have it locally somewhere and not globally available within your application where you need it, and you have to do, I don't know, static fields or getter cascades to get to the driver. We want to create something that gets pre-configured for you, and you can use it within those frameworks. And this is pretty cool. So we were focusing then for Quarkus, Spring, Helidon, and Micronaut. And we were not only focusing on creating or helping those teams to support the Java driver in those frameworks, we also at least tried to have the same convention for the properties. I'm looking at you, Micronaut, because you don't have this right now. But as you can see, this configuration or this pattern, I hope you can see the cursor going around there, is exactly the pattern you would have when you call the driver's configuration. If you want to configure a driver, so you have something like driver configuration set URI. You have something like driver configuration set authentication. And then within this authentication, there is this username password. So, and not to confuse anybody, we talk now about the pure driver. When we look at Spring Boot, we'll see this in a bit, there is more. But all of those 4 frameworks now have in common that you just throw in the Java driver dependency for, I don't know yet, I think for Helidon and Micronaut, you have to enable an additional dependency just to get this configuration started. In Spring Boot, this will get auto-configured. So if you have a Spring Boot application, you just throw in a Java driver without any version, because the version is, as it used to be a Spring Boot, is managed for you by the current Spring Boot version that you are working with. And you provide those parameters, you will have in the end nothing more than an injectable driver. But it looks so empty, but this is great. You don't have to see where to get an instance from. Do I have to reestablish a connection or similar things? That's all the pre-configured driver. You can get it injected where you need it in your servers, for example, or in your repositories, and you can work with this. So taking the things a little bit further, as I said, I'm working at Spring for Neo4j at Spring Data Neo4j. So Spring Data Neo4j takes it a little level higher. So what you have seen before is I use a driver or I use procedures to create an instance of the actor by hand. Spring Data at some level also supports this to do this, but most of the parts of Spring Data is automatic mapping and hydration of your objects. So this is, you get a node that looks like something you have described in the Java world. And this node will get mapped as this, as an instance of this object. But yeah, we see this in a bit. And taking a step back right now, when you're waiting for this, Spring Data Neo4j just came out, well, I think half a year ago, or a little bit more. There was Spring Data Neo4j 6, where we put in a huge amount of new features. So we have now support for reactive programming. We dropped the support for HTTP and embedded, in benefit of having a pure and 100% type safe Java driver dependency on this. With reactive programming and the approach of getting records mapped and streamed fast, we had to care about immutable mapping. So there's now no way that you can just collect everything first within Spring Data, and then Spring Data will figure out what to map where. It has to be record-oriented. It gives you the benefit of having a really fast mapping library in the end. There's now, like it was before with SDN5, a cleaner separation, but still a good Spring Boot integration. So a cleaner separation between the Java driver configuration, as you have seen it in the slides before, and the Spring Boot integration just for Spring Data Neo4j. Yeah, we tried to tackle one problem we particularly had before, that is surprises. So we tried to make it opinionated in some way, but for you as a benefit, you have less surprises when you use this library. It might be more restricted in some ways, but we do not have ambitious behavior anymore. And then we come to also one of last but not least points here is the sensible abstraction layers. So as I said, we have now, when you drop in the Java driver into a Spring Boot application, already an auto-configured driver available. And if you use this Java driver directly, if you provide the dependency for the Java driver, SDN will automatically make use of this Java driver, of this configured instance. There's no parallel instance that is somewhere provided by Spring Data Neo4j. It's always based on this very pre-configured Java driver. And those abstraction levels we introduced now are in the top left box. This is a Neo4j client. That's something that this is the only communication point with the Java driver we have. But it's important if you want to have something that's not so aligned to your modeled objects. On top of this, we have the Neo4j template. The Neo4j template is aware of the object description you gave it. And the repositories who then abstract yet another time to provide this derived finder methods or similar things, just pre-configured CRUD methods to work with objects and to get it stored as nodes in the graph and all its relationship, of course. And we think it's sensible to have all those abstraction and provide it to you. Also important fact is that all those three things in the box are participating in Spring Data transactions. So you can switch the levels of abstraction within one transaction, for example. So starting with the lowest abstraction we have. This is the Neo4j client, and that's yet again the very same query we had before. And you can see, besides a more fluent API, we introduced something that is aware of how should the object in the end look like. It's still the same actor we have seen before. But now I get an even more broader access to all the data available. It's not only the record anymore, but also the type system. So you can work directly with the driver's type system. For example, if you use spatial types, or if you use date times provided by Neo4j that are more complex than just a string, like in this example, you can use this. And then also in this example, I just created by hand again on this low level, because the actor we have seen before has no meta information or similar about what we want to fetch. And if I execute this, I get a very similar picture back like we had before in the browser when we called the procedure. And now we're taking things a level up. The actor is not just a plain object anymore, but a meta or an annotated class with meta informations on it. So an actor is described in Spring Data Neo4j as a node, as the movie is now. We don't only want to have the titles in this example. Of course, there's also a title just within in the movie, but it's now an object or a class definition. You could imagine to have also the release dates. I think the release date is one of the properties you can fetch. But we can now model this more. We can say an actor has a relationship to movies, and it's going to act it in. So the actor then can access the movies later on, if we fetch the data, we do not only fetch the data for the actor itself, but also for the connected data, so the acted in. And having this example might lack a little bit. I just assume an identifier should be something unique. Names are somewhat not so unique, but for this example, don't be surprised. I keep now the identifier for the actor, the name, and for the movie, the title. Not the best business example, but good to see the in the later slides that it not get so complex. Now we get with this meta information provided, we can now use the template. The template, as I said, is aware of those meta informations. So I can use a custom query, for example. I could also use, in this case, just the find all. But to show you this, with the very same query we had before, more or less, it's also possible to just say, I want to find all the actors that come back from this query. If there are more information on this, and I'm aware of this relationship between actor and movie, please consider this SCN. So when I do this, I get exactly the same result back. So no custom mapping or manual mapping involved anymore. It just works. Taking this yet another level up, we have the repositories. So I could define an actor repository. This is this style Spring Data uses. So we're extending another interface. And with this, we get all the quad mechanics. So we can find by ID, delete, save, and similar things just with this repository. So we can also get this injected somewhere and use it where we need it, for example, in a service class. And then do something like we want to find an actor by ID, typically optional. So that's the reason why there's a get ID back. And as I said, the ID is now the name. And this call gives us the very same example as we had before and before back. So repositories are not only there to just provide this functionality, you can extend them. You can use so-called derived finders, so you can do something like find by name to just declare those methods without any code written, without any Cipher written. We generate the Cipher for you that's matching for your domain. That will also fetch, for example, the defined movies there. So now leaving application framework sides. I want to show you something that's really cool, and we created parallel to Spring Data Neo4j 6. It's a Cypher DSL. With the Cypher DSL, you get a fluent API to produce Cipher statements. This example lacks a little bit because it now got so feature-rich in the latest releases that I cannot just show you everything, because you won't see anything anymore on the slides and get confused. But the Cypher DSL is a dependency-free library that you can use if you don't want to use, for example, this Java driver in a configured application, or the Java driver at all, just want to create Cipher strings, I don't know, queries somewhere. You can not only use this fluent path, but as you can see, you can produce also paths you can then chain together to get reused somewhere, as I do it here in this example. And that is also aligned with the example we had before. I could also add parameters to this, to just have this query with the parameters. There's a lot of supported features. We support subqueries also. We support function calls. We took the most used function calls that are provided within the database, and you can just use them and chain together. and similar things. There's also an integration to Spring Data Neo4j back. So we have a Cypher DSL, condition as an extension to the repositories. So you can then just write Cypher DSL conditions to filter things or similar. That's pretty cool. So if you are not interested at all in all this fancy tech stack I showed you, the Cypher DSL is dependency-free. You can use it. And it's getting used, for example, by the GraphQL Java library, where we also aim to make you write less Cypher, use more Cypher DSL features and Cypher DSL GraphQL Java features that creates the Cypher for you in the background. And another thing, we removed functionality from SDN5 and Neo4j OGM with SDN6 that came in the direction of index creation, constraint creation, and similar. We got you also covered there. My dear colleague Michael created this tiny library called Neo4j Migrations. It's a database versioning library. So you can have migration scripts executed either via a terminal as an executable, via a Spring Boot starter, or you can just manually call them from your Java side. This will help you to have migration scripts to take your database to the next level. So you can also always see which version I'm using or from which version I need to migrate to another version and similar things. And I think including the our free offering that were presented earlier today, everything is free. Yay! So you can download your Neo4j instance. You can use Spring Data Neo4j. And you might have seen that I've skipped one slide. If you want to use Spring Data Neo4j, go to start.spring.io also. Just add the Spring Data Neo4j library as a dependency and create your project there. The Cypher DSL, Neo4j migrations. If you need any starting informations, we have developer guides for most of those libraries. And if you're completely lost somewhere, we are here to help also. So either join our discourse forum at community.neo4j.com or our Discord channel, where I think, starting with today, more and more people will arrive. That's all from my side. I think I covered Adam's early ending good enough so that we are back on track in time. Have a nice day. Thanks you for joining. See you later in the Q&A.